Hi everyone, my name is Dr. Basner. I'm one of the lab coordinators at Loyola University of Chicago. You recently did a simulation on fermentation, and now we're going to show you some ways that you can do fermentation in your home using simple and household ingredients. So first up, we have bread. If you've been paying attention to this pandemic recently, you probably realized making bread at home was one of the jokes. It's pretty easy to make. You can buy bread yeast at the store. This is a brand called Fleischmann's. You can buy in bulk or you can buy little packets. To make a simple bread, you'll need some salt, some flour. This is bread flour, but you can also use all-purpose flour and it works just fine. And you need a good source of water. You can use tap water as well, but I brought some spring water to avoid the chlorine. Here's a close-up of bread yeast. You can see it's a small cylindrical pellet-type compound. It's very inexpensive. This whole jar cost me a few dollars, I believe. So to make your bread, the first thing you need to do is add your water and then add your yeast, which is called pitching your yeast to the water. This just gets the yeast ready to be solvated and gets it ready to work. So you need about 2¼ teaspoons for a simple bread loaf like this that I'm going to make. So after throwing in the yeast, I give it a quick stir. Then you want to let it sit for a few minutes and observe it and just make sure that you are seeing the yeast being active and starting to bubble just to make sure that you have a good batch of yeast. So here you can see all the bubbles forming. So that tells me that I have a good container of yeast, and now I'm ready to continue making my bread. The next thing we're going to do is add our flour. I'm going to sift in about 500 grams of flour. So I initially had about 375 milliliters of water. That comes out to be about 1½ cup of water and about 4 cups of flour. You don't necessarily need to sift it in, but I find the bread is a lot nicer if you do. So after adding the first 2 cups here, I'm going to stir it in to mix up the initial bit of flour with the water. It's going to be a very sticky dough at this point. Once you start adding a little more flour, it gets a little tougher to stir it with the spatula, but we'll see that here in a few moments. Alright, now I'm adding my 3rd cup of flour. I got this going on a little faster speed here so we don't take forever. So let's mix in the 3rd cup of flour. Now at this point it's a very thick dough at this point, but it's still sticky. Okay, and now we are adding in the 4th cup of flour. There's no way I'm going to be able to stir it with that spatula at this point. So this is when you start getting your hands in there and working the dough and start kneading the dough. I'm going to take a few moments to try to work all this flour into my dough. At this point it's soft and pliable, but it doesn't really stick to your hands at this point. And plus my hands are covered in flour, so if it is sticking to your hands still as you work through the dough here, you should probably add just a little bit more flour until it's no longer the case. So as I work in all this dough, or all this flour, the dough becomes a nice ball. I'm just kneading it, kind of folding the edges over and then into the center. I'll do this for a little while just to help express the gluten that's in the wheat, so it's helping the wheat start to break down. That's going to make it more accessible to the different yeast. So as I fold over the outside edges into the center, the bottom side becomes a little bit rounded. So I transfer the dough over to the countertop. This helps me press the dough a little better and get some of the air bubbles out of the dough. So as I just round the edges over, I form a nice little dough ball. Now at this point, I'm going to let it sit for about 60 minutes, and this will cause it to rise. The CO2 that's released as part of our fermentation reaction gets trapped inside the dough, and that causes this dough to expand or rise. And this takes about 30 minutes, but I have it on like 160 speed here. So after the 60 minutes up, this is when we shape the dough to get it in whatever shape we want to cook the dough in. You could use a little bread pan. I'm actually doing it in a cast iron pot. which is a common way to make a traditional bread like this. And so I just round it up into the same shape that I initially had it and place it in my cast iron skillet. Then I'm going to let it rise, or proof it's called, for another 60 minutes. And then this will do another rise, so more CO2 is being released. This dough ball is going to expand out to take the final shape of what it's going to look like after it's cooked. One thing you commonly see with these traditional loaves is scoring on the top. Really good bread makers can make these really nice patterns. I'm just doing a slight X pattern. And what this does is as the dough cooks, it's going to expand. And these cracks will basically help prevent your bread from cracking open as it cooks. And you get to do it in the style that you like to do it. Some people draw these really neat artistic leaves, but here I'm just lightly scoring the top to make a little X pattern. So I toss this in the oven at about 400 degrees Celsius for 45 minutes or so, checking every 5 minutes there towards the end. Then once it's finished, I get a nice, beautiful loaf of bread. The parchment paper I had it on was sticking to it a little bit, and so hopefully I use better parchment paper in the future and that doesn't happen. So after letting it sit for a little while, we can cut it open and we can see what it looks like. And now we have a delicious, steaming, hot piece of bread. Next up, we're going to have a look at kombucha. So kombucha is a very popular drink that you see at a variety of stores. This was a picture I took at Whole Foods, but it's also available at places like Aldi's or Mariano's. And kombucha is a fermented black tea. So you start with some sweet tea, then you add the yeast, which also has some bacteria in it in this case. And then the yeast and bacteria take the breakdown of the sugar and turn that into a combination of CO2, acetic acid, and ethanol, and cellulose, among some other byproducts. And so the cellulose byproduct in the liquid that's produced is what we call a SCOBY, or symbiotic colony of bacteria and yeast. And this is done in an anaerobic environment, so all the ethanol eventually gets converted to water and CO2, and there's very minimal ethanol left over. Here's an example of a SCOBY. Some people say that the SCOBY is just this part, the cellulose part, but a lot of people also say that the liquid underneath is also part of the SCOBY. So when you want to make a kombucha, you have to have one of these SCOBYs. So this was a starter material that I found at a local beer and wine store. It's a little expensive, more than I would typically want to pay just to make some kombucha, but you can see the SCOBY plus some starting liquid inside of the little packet. So there is ways to make your own SCOBY, which you can then use to make kombucha. And so we'll show you how to do that. This is some kombucha I bought, I think, at the local Aldi's. You can kind of see the bacteria and yeast down there at the bottom. It's not the best. You don't see that nice disc like you saw on the starter material. The one in the ginger kombucha I have here is a little better, but still not the greatest. But it'll still work if you set it up right. So back behind my kombucha, I have a black tea that I just made and let it cool down to room temperature. It's just in a large, sterilized half-gallon mason jar. So after removing the bags here, we got to add a little bit of sugar, and the sugar is what the yeast is going to use to make your carbon dioxide and your acetic acid and your ethanol. So we dump that in. Alright, so now I'm going to add about a cup of the kombucha liquid. And this contains all of the bacteria and yeast that we need to do our fermentation of the sugar that's in our black tea. So once we add our liquid here, I'm going to cover it and give everything a good shake just to make sure everything and the sugar's all dissolved, everything's mixed up well. and everything's a nice homogeneous solution. And so we want this fermentation to be an aerobic fermentation. So we don't want to collect the ethanol that's produced by our yeast. We want it to eventually turn the ethanol back into water and carbon dioxide via respiration. So I just put a light cheesecloth over the top, and I'm going to let this sit for a long time until my SCOBY develops. One thing I'll comment on before I added the black tea, this was the sanitizer solution I cleaned out that mason jar with. So iodine is a common sterilizing agent. If you've ever had surgery before, you probably had iodine, rubbed on your knee or wherever you're getting surgery on beforehand. So it's a very good tool to clean any wild yeast or wild bacteria that may be on the equipment that you're using for fermentation. It's going to be really important in the next thing we show you here. And so here we have our initial SCOBY forming. This has been about 1 week or so since I mixed it together. And I don't have time to show you the rest in the final kombucha making, but there are some videos online you can probably find. So next up, I'm sterilizing a large 1.4 gallon container. This is going to be for the next home fermentation project. So here's me just using the iodine solution to sterilize this large container. Just kind of seal it up, give it a good shake. So I got my container sterilized and I gave it a quick rinse to get all the excess iodine out. Now this is nice, clean, and sterilized and ready to go for the next project. So the next thing I'm going to make for this home fermentation activity is mead. So you might be familiar with these different alcoholic beverages. If you're ever had wine, that's made from the fermentation of grapes. Beer says it's made from hops, but it's also made from the fermentation of malted barley or grains or wheat. And the hops is really more there to give it the flavor. The hops isn't fermented. You can make cider by fermenting apples or apple juice. In fact, you can take some store-bought apple juice and add some black sugar and yeast and make some cider at home. But what we're going to be making today is mead. So mead is a wine that uses honey as a source of sugar instead of grapes. It's a very traditional drink. It's been around for thousands and thousands of years now. And so I got some pure honey from a place up in Michigan. You need about 3 pounds or so for every gallon of mead that you're going to make. Then I also got some raisins because there are not a lot of nutrients in honey on its own. So when you're making wine, wine has all these micronutrients and whatnot in it. And the raisins are there to provide those micronutrients to the mead, which allows the yeast to grow well. We want to do this in an anaerobic environment because we want the ethanol to stick around. So here I have a little bubble or airlock, and so the CO2 will drift up through that center tube. Then it'll be pushed through some water and eventually go outside. But the airlock prevents any air or anything else from outside getting back into our container. So once you start producing yeast, your whole container fills up with carbon dioxide, and the bubbler allows any extra pressure to be released outside the container, so you don't build up a bunch of pressure and make a carbon dioxide explosion in your house. Also, just add some yeast nutrient. This is a common thing you can add just to make sure yeast has everything it needs to grow properly. I'm going to add a small tablespoon of this just to help promote my yeast growth. So here's the yeast I'm going to use. This is a wine yeast. It's bred to have just a slightly higher alcohol tolerance compared to some other types of yeast. It's pretty inexpensive, just like the bread yeast. But for the most part, it's the same strain, Saccharomyces cerevisiae. So first I'm going to add a little bit of water, just so there's some water in there to get everything started. The last thing I'm going to add is my yeast. So I also added a teaspoon of my yeast nutrient, just a handful of raisins, about a cup or so, and then just under 4 pounds of honey. There's some markings on the bottle here that I'm looking at to measure this. And that'll give me about 3 pounds for every gallon of liquid I have. Last thing I'll do is top this off with water to fill it up to near the top, right around the 1.4 gallon mark. So you want to make sure that the honey is mixed really well together. It's very sticky, so you got to stir this for quite a bit just to get the honey to dissolve and get everything else to dissolve. So I'm going to fast forward this a little bit and you can watch me stir it until it is complete. The last thing we need to do before we add the yeast is measure the initial density. So when you want to calculate the percent alcohol by volume of an estimated percent alcohol by volume, we need to find the starting density, which the density is going to change depending on how much sugar you add to your initial mixture. And so wines tend to have a very high specific gravity at the start. So specific gravity is essentially density. The big difference from specific gravity and density, however, is that with specific gravity, you assume that the density of water is at 1. So this makes it independent of the temperature. And it tells you the density as a ratio of water compared to whatever the solution you're measuring is at. So we can see here that there's the meniscus of our solution is right about the bottom of that little green arrow in the green portion of our little density meter here. And so what these things represent are the initial starting gravities of where you want it to be depending on the type of material that you're making. So right here you can see I was at about 1.095 or so, which is about where you want to be if you're making table wine. If you're making a dessert wine, which is a much sweeter wine, you want to have more sugar in it, therefore a higher starting specific gravity. And so if we look at some of the other regions here, right, there's an estimated percent alcohol on the other side, so it tells me I'm going to be about 12% alcohol when this mead is being finished. So above the table wine section, this is the orange section is where you want to start if you're making a beer. Those usually start about 1.04 to 1.06 or so, depending on the type of beer you're making. That usually ends up in that 4 to 6% alcohol by volume. And up at the top, it tells you where you want to be when you're finished. Okay, so now we have to pitch the yeast. We'll just open this up, dump it in, and give it a quick stir to make sure everything's mixed up well. Then our fermentation is essentially ready to start. All right, now that everything's mixed, I can seal up my container and just let it sit. I do need to add the bubbler to the top here, and that prevents any oxygen from getting into our system. So I add a little bit of water up to the little line here. It's hard to see in this video, but I promise there's a line there, and cap it so the little top doesn't come out. A couple days later, we see our reaction fermenting vigorously. The CO2 is being released into the container, and then our bubbler is allowing the excess CO2 to escape, but the oxygen is not getting into our system. All right, so this right here, this is about 4 days later. You can see the raisins are really starting to lose their color. We got a little waste product forming at the top ring there, and we're still bubbling quite vigorously. About a week later, you can see a lot of the bubbling has stopped. The raisins are very clean at this point. We don't really see any noticeable bubbling. You might see one every week or so. And then down at the bottom of the container, we see a lot of sediment resting at the bottom. And so I tested the specific gravity again, and you can tell it's not quite done. It's about 1.005 or so, and we want it to be slightly under 1 to be finished as a wine. So I did want to put it in a new container to get rid of that sediment at the bottom. That can leave a bad taste if you leave it in there for too long. And so I emptied out the container. Here's kind of the excess waste and raisins there at the bottom. So I cleaned out my container and transferred the liquid back to it. And you don't really see any bubbling right away, but eventually you'll see a bubble show up every minute or so. Then I'm going to let this sit for about 6 months or so until it'll be complete. After another 2 months, I will probably bottle it and then let it sit for another 3 months or so. So this is a bottle of finished mead that I had made last summer or so, which is ready to drink. This particular batch was a apple cinnamon mead, which turned out fantastic. So I hope you enjoyed the video, and I hope gives you some neat ideas in fermentation you can do at home. So fermentation can be a fun hobby if you're looking for something to do at home. There's all sorts of things you can ferment. Really, you can ferment almost anything. But I hope you enjoyed it and you start to see some connections to the labs or simulations you've been doing in class.